Example 2, prove a over b to the nth power equals a to the nth over b to the nth. Assume a and b are constants with b not equal 0. Of course, b can't be 0 because then we'd have an undefined fraction there. So go back to your steps. Step 1. Show S1 is true. So typically you're either going to look at the first term or you're going to plug in n equals 1. And that's what we're going to do. So, check it out. You've got a over b to the first power equals a to the first over b to the first. And that's pretty obvious that a over b equals a over b. Okay, so that's true, right? So S1 is true. I've just showed that you knock over the first domino. First domino false. Step 2 is the hard part. We want to show that if SK is true, that's going to lead us to SK plus 1 is true. So in other words, back to the domino analogy, I'm showing that if there's some domino off in the future that falls, then the next domino will also fall. And if you can prove that, if you can show that, then you show that all the dominoes fall, and you've proven this for all of the n. So start by an assumption. And remember, that's where we're just going to change the n into a k. So k is just some number off in the distance. All right. So we're going to assume that's true. So that's just some domino off in the future is going to fall. Now I have to prove that the next one is going to fall, and that's where k plus 1 comes in. So change that k into a k plus 1. Likewise here and here. And technically this is a question. We don't know if that's true. That's what we're trying to show. That's what we're trying to prove. Okay. Now, sidebar, we have to think about some algebra for a second that you may have forgotten about. Okay? So, come down here, I guess. You don't need to write this down, but think about it. If I told you x to the second times x to the fifth, I think everybody in here would know that that's x to the seventh. Okay? That's a terrible 5. Let me try that again. X to the second times x to the fifth is x to the seventh. We all know that rule. You're adding the exponents. But what gets trickier is if we talk about a variable as an exponent. If I said x to the k times x to the second, you should use that same rule and say that's going to be x to the k plus 2. Because we are adding the exponents. When you multiply powers, you add the exponents. Okay? So if you just have x to the k times x, you can think about it as x to the first. If you add those exponents, that's x to the k plus 1. Or you're going to have a to the k plus 1. All right, so think about this. We need to go backwards. All right, what we have is a k plus 1 exponent. You need to be smart enough to go backwards and understand how to split that up. If I have an exponent k plus 1, like I do up here, it would be nice if you could understand that that could be split up in this way. We're multiplying two powers, which is how we ended up adding those exponents. All right? So that's my left side. I forgot to draw my line. You don't have to draw that line, but I think it helps sometimes to keep the left side separate from the right side. So notice we can do the same thing on that right side because we have a to the k plus 1, so that must be a to the k times a to the first over b to the k times b to the first. Now remember, this is a question. We're trying to show if that left side is equal to the right side. Are those two things true? All right. Well, yeah, because we can just split this up on the right. that a to the k over b to the k, we can split up and call that a over b to the k. Likewise, you got a to the first over b to the first. We can split that up and call that a over b to the first. Those two things are obviously equal. All right, we just did what we needed to do, QED. All right, so I might wrap this up and say, therefore, Sn is true for all positive integers n.